Okay, great. So I know that you're going to put in the rest of the exit tickets from our last reteach today or at the end of the day. So we'll check to see how progress was on last week's reteach. But let's go ahead and jump into this week. So today we're going to dive into standard 3 OA5, which was the focus of last week. So it was a challenge for scholars. We had 10% mastery overall. And then the two questions that we're going to dive into, questions 4 and 5, had 30% mastery. So it's a really good one to dive into because it's a big focus for the year. Let's go ahead and start by just taking 2 minutes to break up what scholars need to know and show, and then we'll show. All right, great. Let's go ahead and jump in. Why don't you start with no? What'd you have? Okay. Yep. Great.
Add accurately and then break apart numbers. Yeah, so I just said that break apart numbers with addition. So that's what I put in now.
Great. I had a few of those in show, but either way, I think that works. Let's even talk about some of the properties that are in the standard actually, and let's see if we can put them in kid-friendly language. So the first one, the commutative property, which is 6 times 4 equals 24, then 4 times 6 all equals 24. If you had to put that in kid-friendly language, what would that understanding be? The very first one.
Okay.
So what do we know about multiplication?
Size equals total, and then size times group equals total.
Yep, great. So let's add that. I just had the idea of like when you multiply, you can multiply in any order, and it's the same.
Okay.
And then let's talk about the associative property. So look at that next section. If we had to put that in kid-friendly language, what would that sound like?
Which one is
that? The 3 times 5 times 2, then 15, then 3 times 5 equals 15, then 15 times 2. Yeah, you're good.
Multiply beginning on the left side and go through all the numbers?
Yeah, at the beginning, I can start by multiplying any two numbers and then multiply that product by the other products. So let's add whatever notes make sense for you for the associative property.
Okay. Yeah, because that's what comes.
And then take a look at the last one, which is the distributive property, which is going to be the focus for today's lesson.
Okay.
And if you had to put that in kid-friendly words, what would it sound like?
We distributed, what I tell them is we make multiplication easy. So when we do that, we have to break apart numbers to make primary numbers.
Great. Yeah. So I had like decomposing or breaking one factor to smaller parts and then adding those parts together. Okay. Great. So that's the last one. Those three, they don't need to know them by name, but they need to know like that they actually work. Great. Let's go over to show. What do you have for show? Yep. 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 Also, just like rewrite an expression correctly. So if I'm rewriting it to make it match, make sure that happens. And then last, just solving both sides of an equal sign to make sure that the two sides are equal. Yep. So I'm going to dive into specifically questions 4 and 5. On these questions, scholars got I think like 29% and 30%, basically the exact same percentage. This is an exemplar. I want you to take a look at this exemplar and tell me how does it demonstrate mastery of the standard. What do you see?
They rewrote the example.
Mm-hmm. Yep.
Talk apart the numbers. And yeah.
And then they obviously like found the correct values, right? And then what do you? Yep. I guess this one isn't, but you can imagine. And then what do you see them doing right here? Yeah, so double checking using or multiplying or adding on both sides. Great. We didn't have necessarily an exemplar among students, so I want to jump straight into the gap work for students. So this is some of their work. Why don't you take about a minute and a half to look at questions 4 and 5. Most of them are like the front and the back. And I want you to think, what's the gap between the exemplar and that work right there? Let me just do a minute and a half. What do you see? Mm-hmm. Yep, so we saw I didn't check their work, and then to your point, tell me more when you're saying they didn't, yeah, what's going on right here? What mistakes are they making when they're rewriting the expressions?
Or like here. Exactly. Oh, was it a 3 or no? It was an 8.
I think it's an 8. For some reason, they had 8 and 5.
Yeah. Yeah.
So
They didn't accurately. They don't know how to break apart the numbers. Also.
yeah, they're not decomposing them, right? So their expressions are right. So what do you think is the conceptual misunderstanding that's leading to this error? What do scholars not understand about the distributive property?
They don't understand like when you're distributing or decomposing, you break apart one number to where that each sign in the middle, they're adding that up together.
Great. Great, so let's each take a crack at filling out this statement right here on the front page. The students did not because they did not understand, and then let's share in a minute. So let's take a minute to write what we think the error statement is. So students did not, what was the error they're making? Because they did not understand what. That's all right. The sugar probably is hard to put in words. Go ahead and share what you have, and then I'll share what I have. I had students did not identify equivalent expressions because they did not understand that one factor in a multiplication expression can be broken into smaller parts and then added back together.
I like that
Because it's only one factor.
yeah, it's because they need to like,
Mm-hmm. So why don't you go ahead and update it? Here's my notes right here in case it's helpful if you want to just do that section right there. I just added and then added together. Great. Okay, so based on mastery and the work that we saw, should this be a model or a guided discourse? And why do you think so? Yeah. Yeah. And also, we don't have a clear exemplar, like student exemplars aren't clear, so we can't really use their work for guided discourse. So because this is such a meaty standard, and because it was already taught once and it didn't stick with scholars, I went ahead and put together what I think is a strong reteach lesson, and I want us to work on internalizing it to make sure that we're stamping some really key points. Does that sound good? So if you flip to the next page, what you'll see is this front page is the script for the opening task and the model, and then the behind it is the student packet. Okay, so what we're going to do is we're going to do a little bit of practice for each. I'm going to give you about a minute to review the reteach opening task and look at the materials, and then I'm going to model it, and then I'm going to have you model it. All right, and then we'll do the same thing for the model. As you look at the reteach opening task, actually, nope, just read it, and then I'll do the next question. Just the opening task part. Yeah. All right, let me go ahead and model it now that you've had a chance to read it. And I want you to think specifically, how does this stamp our key conceptual point? Okay? All right, so scholars, you have the page in front of you. There are 4 different problems on your page. Everyone take 2 minutes to fill in the blanks with the correct answer for all 4 problems. Let's go. You're filling them in. Great. What's the first one, Miss Meeks? E equals 30. What's the next one, Jamar? What's the next one, Jose? And what's the last one, Heaven? Scholars, what do you notice about all 4 problems? What do you notice about all 4 problems? Miss Meeks? Yeah, all of them are equal to 30. All of them are equal to? Good. Why are all of these equal to 30? Why are all of them equal to 30? Why are all of them equal to 30, Jacob? Yeah, in every single one, I have 6 5 times. I know 6 times 5 means 6 5 times. On this one, I have 6, 1, 2, 3, 4, 5 times. This one, 1, 2, 3, 4, 5 times. This one, 1, 2, 3, 4, 5 times. If I wanted to, let me look actually specifically at these bottom two problems. If I wanted to write this part of the problem, I could write it as 6 3 times, and I could write this part as 6 2 times, and I know that's equal to 30. So I have now 6 times 3 plus 6 times 2 equals 30. How do I know, just looking at this expression, that I still have 6 5 times? How do I know that I still have 6 5 times, Miss Meeks?
Because 6 and 2
Good. 3 and 2 equal 5. I know I have 6 and 3 here and 6 and 2 here. So 3 times and 2 times equals 5 times. Let me look at this last one. I know that I have 6 one time here and 6 4 times here. When I say go, turn and tell your partner, how do I know that I still have 6 5 times? Turn and tell your partner. All right, come on back. Why do I know I have 6 5 times, Miss Meeks?
1 plus 4.
Good. I have 6 one time here, 6 4 times here, and 1 plus 4 equals 5. Scholars, we know that when we have a multiplication problem like this, we can take one of our numbers in the multiplication expression and break it down. We can break it down to make multiplying easier. All right, and C. So how did that stand? The key understanding that we talked about when we unpacked the standard. Yes, and the good thing is, right, like this is also reminding scholars that multiplication is repeated addition, right? And that this is an easy way for scholars to see different groupings of repeated addition, right? Okay, great. Let's go ahead and have you stand up, and we're going to have you model. And I can be any scholar you want me to be. All right, whenever you're ready, you can go.
So here on page 4 different equations. When I say go, I'm going to give you 2 minutes to have an answer for every problem. Go.
All right, hold up.
Back to me. 6 times 5 equals Justin.
30.
Okay. Next one. Answer Justin.
30.
Next one, Jamar.
30.
Next one, Jose.
30.
Scholars. Now that we've completed and we have answers to all problems, what do you notice about every problem that we solved? Justin.
All of them are equal to 30.
Yes, all of them are equal to 30. So, okay. Okay. So now, when I say go, you're going to turn and tell your partner, why do you think all of them equal to 30? Back to me. Justin.
All the problems have 6 5 times, so that's why they all equal 30.
Yes, that is correct. You're just
Yeah.
yes, scholars. So scholars, I'm sorry.
You good? Right here.
Okay.
This part right here.
Okay. So scholars, let's take a look at these last 2 problems. Now I'm looking. I see in parentheses I have 6 plus 6 plus 6 plus 6 plus 6. So if I wanted to rewrite that as a multiplication equation, I know that I have in here 6 times 3, that's 6 3 times. I'm going to put it back in parentheses. Plus, here I have 6 2 times. So that's 6 times 2. And I know that will still equal 30. Now, looking at this equation, just this one that I just rewrote, how do I know that it's still 6 with 5 groups?
6 5 times.
Okay. How do I know it's 6 5 times?
Because you have 6 3 times, and then you have 6 2 times. So 3 times and 2 times is 5 times.
Yes, so I see. Okay. Yes. So I can do the same on the second problem. So now, I see here in parentheses, I have 6 1 times. So that's 6 times 1. That'll give me 6. Plus 6 times 1, 2, 3, 4. When I say go, you're going to turn and tell your partner, how do you know this is 5 groups of 6?
How do I do it 6 5?
Okay. I gotta get there. How do I know that this is 6 5 times? Justin.
I know because you have 6 1 time and 6 4 times, and 1 plus 4 equals 5.
Good. So that is correct. So that still equals 30. So scholars, we know that we can take one of our numbers in a multiplication expression and break it down. Break it down. Break it down to make multiplication easy.
Good. And see. Nice.
I'm trying to think, like last week, I did teach them like a strategy. So we broke it apart and this one stayed the same when we rewrote it. So I was thinking like, instead of like, I can like rewrite this, right?
So I was going to say.
And then I can go back to this, since we know it equals 30, and I can say, okay, turn and tell your partner, which one of these factors did we break apart? And then that's, that'll be easier because that's how I kind of taught them.
Yeah.
So which one did they break apart? Turn and tell your partner.
Good. Let's add that to your script. Okay. That's a good one where like, I almost feel like it could fit before this one, right? Yeah. Like let's add that. You can say like, how do I know that's still 5 times? So what factor did I break apart? I like that. Okay. Good. So let's think. So you would do let's say, how do I know? I'd say 3 times and 2 times equals 5 times, and then you would ask this one.
Yep.
All right. Let's go right into that. So I know it's 6 5 times because 6 3 times and 6 2 times is 5 times.
That is correct. So look at the first equation. We know that they broke apart the 5.
I really shouldn't ask the question.
Okay.
Right. So look, we had 6 times 5.
Oh,
which factor did we break down? Yeah.
So now, scholars, now that I'm looking at this equation and looking at this one, I know they both have the same total of 30. When I say go, you're going to turn and tell your partner, out of this equation, which number did I break apart to create this new expression? Go.
She broke down the 5 because I knew she had 6, and every single one of the groups, she's just changing how many times she gets.
Back to me. So which one did I break apart, Justin?
You broke apart the 5 because it was 6 5 times, but then you made it 3 times and 2 times, but the 6 was always the amount in each group.
That is correct. So scholars, when we decompose, when we decompose expressions.
I think it's actually, I think you can just say, scholars, we know that when we can take one factor, if you want to change it to factor, we can take one factor and break it down. Break it apart, that works. So I think you could even say, right, like you could say, okay, so after they said, I know 5 is the factor. Good, scholars, in this problem, we took 6 times 5, and we took this factor and broke it down into 6 times 3 and 6 times 2. Take a look at this one, and then you can do the same thing for that one.
Okay.
Does that work?
So that's why we see that they broke apart 5, and we got 6 times 3 in parentheses plus 6 times 2. The numbers that add back up to get 5 are 3 and 2. Now,
because I don't get it. Okay. Let's jump down to the model. So the model, I think, so that it's a little bit easier to internalize. Why don't we flip the order? I will model it really quick, and then after that you can read the script, because sometimes it's hard if you're not actually seeing it in action. So I'll model, and then you can read the script. Okay. So what I want you to be thinking about as I model is how am I directly connecting my model to what we just reviewed in the conceptual understanding. Okay. So scholars, now take a look at how I'm going to solve this problem. It says write 2 expressions that are equal to 9 times 6. I have 9 times 6, and I have 2 different expressions. I know 9 times 6 is 9 6 times. So I'm going to write 9 plus 9 plus 9 plus 9 plus 9 plus 9. 1, 2, 3, 4, 5, 6. I have 9 6 times. I know I can break it into different groups of 9s. Watch me. I'm going to go like this, and I'm going to break that into a group, and I'm going to go like this, and I'm going to break that into a group. I know that this is now 9 2 times, and this is 9 4 times. So I know that I have 9 times 2 plus 9 times 4. But let me check because it says they're going to be equal. Well, I know that 9 times 6 equals 54. I know that fact. Let me make sure that my new expression equals 54. 9 times 2 equals 18, plus 9 times 4 equals 36. Let me add up 36 plus 18, and what do you know? I got 54. So I'm going to put a check because I checked my work. Now I have to find a new expression. Well, I know I need to write 9 6 times. Last time I broke it into 9 2 times and 9 4 times. This time, let me do something different. I'm going to break it down right in the middle. Now I have 9 3 times and 9 3 times. So let me fill in my 3. And one more time, let me make sure that this adds up. I know 9 times 6 equals 54. Let me solve my new expression. 9 times 3 equals 27 plus 27. 27 plus 27 equals, what do you know? It equals 54. Scholars, what did I do to help me break 9 times 6 into 2 more expressions? What did I do? What did I do, Ms. Meeks?
You wrote a repeated addition.
I wrote my repeated addition sentence. I know I had 9 6 times, so I wrote 9 6 times. Then, after I found my new expressions, how did I double check to make sure that it's exactly the right answer?
I went back and multiplied the expression.
Good. I solved this side of the equation and made sure that it was equal to this side. I went back and I checked it. Scholars, you're now about to have a few problems on your own. I'm going to be looking for scholars writing out their repeated addition sentence. And at the end, I'm going to be looking for scholars who are proving their answer is right by making sure both sides of the equation are equal. And see. Okay. So, yes. Mm-hmm.
They don't know how to multiply back to 13, 15, 17. They were doing that too.
So when you said, so if it was, let's say it was 13 times 7. If it was 13 times 7, I would do, or I would write 13 7 times. Oh, then I would just say, okay, like if I said 9 times 3, you know what? I don't know what 9 times 3 is. Oh, but I know 9 times 3 is the same as 9 plus 9 plus 9. I can do that. You know what I mean? Then you have to add it up that way. However, I'm surprised that they had that in the. I'm surprised that they had those type of questions because within the standard, they need to be fluent within 12. So they shouldn't have. Yeah. Yeah. Now I took a look at the practice test and they're either going to see factors less than 12 so that they can use their fluency, or they're going to see multiples of 10, which is when they can just use their understanding of 10. Does that make sense? So I'm glad you brought that up because that they don't need to know that fluently. Okay, great. So now I'm going to give you, why don't I give you about a minute to then take a look at what I just modeled. I might have made a few slide adjustments. For the most part, I follow that, and then you'll practice. Different examples. Sorry, you can do whatever examples you want for that one. All right, why don't you go ahead and pop up?
Now you're gonna watch me and I use what I know about breaking numbers apart to get the same total in the number sentence. Track the board. So I'm gonna read number 1. It says write two expressions that are equal to 9 times 6. And then I see I have 9 times 6 equals 9 times blank in parentheses plus 9 times blank. So now, scholars, now what I'm going to do is, I know when I see 9 times 6, that's the same as saying 9 6 times. So I'm going to write a repeated addition sentence. 9 plus 9 plus 9 plus 9 plus 9 plus 9 equals blank. 1, 2, 3, 4, 5, 6. Going back to check and see if I have 6 9s. Well, now, scholars, I know to get the same total, I can just break these numbers apart. I'm going to put parentheses around them to show me what do I do first. Here in these parentheses, I have 9 plus 9. I know that's the same as saying 9 times 2. Still going to keep it in parentheses because I need to solve that together. Plus, there's my addition sign. 9 plus 9 plus 9 plus 9. Oh, that's 9 4 times. So that's the same as saying 9 times 4. Oh my goodness, these numbers are easy. I can multiply them way easier. Equals blank. Now, scholars, going back to my original sentence, I know when I see an equal sign, both sides must be equal. 9 times 6. Wrote my numbers.
I would I would transfer the numbers.
Oh. Okay. Okay, thank you. Okay, go back. So now that I've had my new expression, I'm going to put my numbers here in my equation above. So I see 9 times 2 plus 9 times 4. Now, I have to make sure both sides are equal to check my work. So rolling my numbers, I know, scholars, that 9 times 6 equals 54. So I know this side must also equal 54. I'm going to check it below here. 9 times 2. Oh, 9 times 2 equals 18 plus 9 times 4 equals 36. Now I'm going to solve. I'm going to write my work over here with the standard algorithm so I can check them above. 8 plus 4. Oh, 6, I'm sorry. 8 plus 6 is 4. Carry the 1, 54. So my work is complete. I know that 18 plus 36 equals 54, and 9 times 4 equals 54. So I am correct. Scott, now.
And I almost wanted to go through this. So I'm wondering, I was wondering if you just need to check the response here and ask y'all to do
this one. Okay.
And now I'm going to ask you to do it in a different way. I did 9 times 2 and 9 times 4. You have to pick a different way.
Okay.
So let's see the check for understanding.
Okay. So fellas, what did I do first to show? What did I do first to write a new expression?
You wrote 9 6 times.
Yes, I wrote in a repeated addition sentence. Then, what did I do to the repeated addition sentence to create a new expression?
You broke up the repeated addition sentence into groups and then wrote new multiplication expressions.
Yes, that is correct. So now, scholars, that you watch me solve.
And one more thing, I think I would just confirm. So you just asked, I would ask that now.
How did I check to make sure that my expressions are equal? Did you ask that?
Mm-hmm.
Okay, I would just do that so that they don't check their answer.
Okay, so how did I check to see if my expressions were equal?
You added one, you multiplied one side, and then you made sure it was equal to the other side.
Yeah. So scholars, now you're going to do the next. I'm going to give you 2 minutes to do the next problem on your own. I'm looking for repeated addition sentences. I'm also looking for scholars to check their work on both sides of the equal sign to make sure they're equal. Begin.
Yep. All right, cool. Great. Perfect. We know it's right about time.
So tomorrow's
lesson is super easy. It's about area.
Yeah.
Area, count the squares, right? Like easy. So that